Okay, so let's have a look at I guess, a family of functions in that we've looked at some like this where we've just got some generic a value or constant term in there. So the graph could look like any one of a number of things. So if we do a quick graph sketch, x minus a is a repeated factor, so we can expect a turning point at x equal to a and a x-intercept at 1. So that's what our graph roughly looks like. All right. Find the coordinates of the turning points of the graph. So from the CAS, we can see straight away what they would be. I do go through and differentiate it by hand later. So just using our derivatives and then solve our derivative equal to 0, we can see where our stationary points will occur. State the nature of each turning point. Well, if you look at the graph, it's clear cut that at the point A0 we have a maximum, and the point A plus 2 on 3 for a minus 1 cubed on 27 gives me a minimum. Find the equation of tangent lines. All right, so this is where I thought we'd do some differentiation. At x equal to 1. So first things first, at x equal to 1, y is equal to 0. So there's the point the line goes through. So now I need a gradient. The derivative, so if we just get the function visible. If we do need to differentiate by the hand, let's just use a little product rule. So x minus derivative of the first, which would be 2x minus a, the power of 1, times the second, plus the derivative of the second, which is just 1, x minus 1, times the first. So again, I've got that x minus a as a common factor. So that gives me with a 2x minus 1 inside plus x minus a. So I get x minus a outside of 2x minus 2 plus x minus a. Gives me x minus a. 2x plus x is 3x minus 2 minus a. So there's a derivative that our CAS has generated for us. All right. So if I put x equal to 1 into that function, down here, I'm going to get 1 minus a squared. So I've got a point, I've got the gradient. So y of tangent is y minus 0 equals m, x minus x1. My gradient, expand the bracket to get my y-intercept. So there's a tangent line at x equal to 1. At x equal to a, it's a little bit more straightforward because if I put x equal to a into my derivative, I get a minus a, which is 0. And if I put x equal to a into the function, I also get 0. So the tangent line, as we'd expect from the graph, because it's a stationary point at 0, my tangent line is a horizontal line, y equal to 0. If x is equal to a plus 1 on 2, things are a little bit messier. So there's my a plus 1 on 2 substituted into my derivative. And so then if I come up here, I've got a on 2 minus 2a on 2 will give me a minus a on 2. If I just expand the right-hand side of fraction, I end up with 3a on 2 plus 3 on 2 minus 2a on 2 minus 4 on 2. Group them together. 3a minus 2a is a. 3 minus 4 is minus 1. Take a negative sign out the front, in particular of the 1 minus a. I get the negative of a minus 1 on 2 all squared. Okay, so there's my derivative. If I want to get my y value, okay, I substitute a plus 1 on 2 into the function. So there's my x minus a all squared x minus 1. Do the same thing. I'll split it up this time, just sort of try and make it clearer. A plus 1 on 2 is a on 2 plus 1 on 2 minus 2a on 2. Get them all common denominators. A on 2 plus 1 on 2 minus 2 on 2. So get all the denominators the same. So we get a minus 2a, which is negative a, 1. So I get minus a plus 1 on 2 in the second bracket. I get a on 2. 1 on 2 minus 2 on 2 is minus 1 on 2. So I end up with the negative of a minus 1 all cubed on a. Now, chances are this is probably a technology active, but it's good algebra practice. So what have we got? We've got a y value, we've got a gradient value, so we've got a point. We've got the point, a plus 1 on 2 minus a minus 1 all cubed on 8, and we've got a gradient. All right, so obviously the minus minus on the left-hand side becomes a plus. Let's expand my bracket on the right-hand side. There's my gradient times x. A minus 1 all squared on 2. So I've just made it a minus 1 all squared on 4. I'll take the 4 out of the square, times a plus 1. I can make them positive now because I've got a negative negative. So staying on the right-hand side, a minus 1 squared. So if I take the 4 and 2 at the front to make it an 8, I'm going to just use one of the a minus 1s. Okay, so that leaves me with an a minus 1 times a plus 1, and that's just a squared minus b squared. So I've just redistributed that power just for a tick, and then I'm going to bring the y value across. And I've got a plus a minus 1 on a minus 1 cubed on 8. So what are we going to do? Let's take that 1 on 8 at the front. I've got a minus 1 as a common factor to both those expressions. So I've got my a squared minus 1, a minus 1 squared. Expand the second bracket, a squared minus 2a plus 1, a squared minus 1. Group my terms together. Leaves me with just a 2a squared minus 2a. I can take 2a out the front, so there's my 2a. And then I've just got an a minus 1, so it gives me an a minus 1 squared, which eventually tidies up to my tangent line, which corresponds to our CAS stump. All right, good lesson, good algebra practice, but again, probably not something that would be in an exam one.